So now we're going to talk about solving absolute value inequalities. So the steps for solving an absolute value inequality is to create two inequalities. One as without the absolute value, the other where you flip the inequality and negate the other side. I, rather than doing that step, suggest that you just do it how we've been doing it, which is you multiply it by a -1. If you prefer to do it that way, you may, but I say or multiply by -1. Then I'm going to solve each inequality, write your solution as a compound. Now, this is very important to remember. Whenever we have a less than absolute value, it's going to be and. Greater than will be or. So here's our example. So we have 3a plus 4 is less than 10. So the first thing I think in my mind is this less than means and. So I'm going to say 3a plus 4 is less than 10. And then, like I said, I like to say -1 times 3a plus 4 is less than 10. Then I solve, subtract 4, 3a is less than 6, divide by 3, a is less than 2. This one I can divide both sides by -1. When I do that, I end up doing what the notes say in step 1, which is it becomes 3a plus 4 is greater than -10. Because when I divide both sides by a negative, I need to flip and change the inequality. So then I subtract 4. I get 3a is greater than -14. Divide by 3. A is greater than -14 thirds. So it's an and statement. So it's really A is greater than -14 thirds. And A is less than 2. So I want you to pause and try 11, 12, and 13, and then I'll come back and do 14 for you. Okay, so I solved these. Again, the important part is the two inequalities. So it's b plus 2 is less than or equal to 3, and then -1 parentheses b plus 2 is less than or equal to 3. So that gave me my and solution because it's less than. So it's -5 is less than or equal to b is less than or equal to 1, which I graphed on that number line. 12, my two inequalities are w minus 2 is less than or equal to 5. Then -1 parentheses w minus 2 is less than or equal to 5. Solved, and my solution set is -3 is less than or equal to w is less than or equal to 7, which I graphed. Same thing for number 13. T plus 2 is less than 4. -1, t plus 2 is less than 4. Got an and for my sentence, and I graphed it. So now number 14 is greater than. So keep in mind that when it's greater than, these three are all going to be or because they're greater than. So again, my process is still the same. So it's 2d minus 1 is greater than or equal to 4, or -1 times 2d minus 1 in parentheses is greater than or equal to 4. So I still solve that the same way. I add 1 to both sides. Sorry about the bell. I add 1 to both sides. I get 2d is greater than or equal to 5. Divide by 2. D is greater than or equal to 5. Here, I'm going to distribute my -1. So I have -2d plus 1 is greater or equal to 4. I subtract 1. I get -2d is less than or equal, is greater than or equal to 3. Divide by -2. And d is less than or equal to -3 halves. I was stumbled because here I said is greater than or equal to 5, but it's really greater than or equal to 5 halves. Notice I can't be less than -3 halves and greater than 5 halves. But a greater than is an or. So I'm going to graph the greater than or equal to 5 halves. So that's a solid circle on 2.5, and an arrow to the right, and a solid circle on -1.5, and an arrow to the left. So I want you to pause and solve 15 and 16. Okay, here's 15 and 16. And again, the important part is the two inequalities. So it's 2x plus 1 is greater than 2, and then negative 1 parentheses 2x plus 1 is greater than 2. So my solution set is x is greater than 1/2, or x is less than or negative 3/2, which I graphed on my number line. Number 16, two inequalities, 3f plus 10 is greater than or equal to 4, or negative 1 parentheses 3f plus 10 is greater than or equal to 4. My two solutions are f is less than or equal to negative 14 thirds, or f is greater than negative 2. Last problem is 17. The government requires speedometers on cars sold in the US to be accurate to plus or minus 2.5% of the actual speed of the car. If your speedometer reads 60 miles per hour while you are driving on, what is the range of possible actual speeds your car could be traveling? So again, we're going to do the absolute value of x minus 60, because that's how fast I'm driving, is equal to 2.5%. Now, it's not really equal to 2.5%, but it's equal to 2.5% times 60. It's 2.5% of the actual. So that's going to be 0.025 times 60. So that means that x minus 60 is, and what is the range? So actually it's going to be less than or equal to that, right? Is less than or equal to, and then I'm going to do 0.025 times 60, which is 1.5, or negative 1 x minus 60 is less than or equal to 1.5. I solved this one, I'm going to add 60. So x is less than or equal to 61.5. Here, I'm going to divide both sides by negative 1. X minus 60 is greater than or equal to negative 1.5. Add 60. And x is greater than or equal to 58.5. So if I think I'm going 60, the regulations require that I'm actually going between 61.5 and 58.5. So tomorrow in class, we're going to work on the additional practice. If you have any questions, please bring them to class.